Mathematics 1, exam paper from January 2016, question 1. Determine the highest common factor and the lowest common multiple of the following set of numbers. The first thing we need to do is to find the prime factors of this set of numbers. I'm going to show you 3 different ways of doing it. So we'll start with 1260. We'll start by finding the prime factors of 1260. That's obviously divisible by 2, so we'll divide by 2 and we get 630. That's divisible by 2, so divide and we get 315. That's not divisible by 2, but it is divisible by 3, so we divide by 3 and we get 105. That's also divisible by 3, so we'll divide by 3 and we get 35. That 35 is not divisible by 3, but it is divisible by 5. Divide by 5 and we get 7. 7 is a prime factor, so that means we've now identified all the prime factors of 1260. The next method we'll use is one that you might have learnt at school. So we write down the number 3465. That's not divisible by 2, but it is divisible by 3. So divide that by 3 and we get 1155. Add 1 to 1 you get 2, add 2 to 5 you get 7, add 7 to 5 you get 12. 12 is divisible by 3, so 1155 is divisible by 3. So we divide by 3 and we get 385. 385, 3 plus 8 is 11, 11 plus 5 is 16. 16 is not divisible by 3, so 385 is not divisible by 3. It's obviously divisible by 5, so we'll divide by 5 and we get 77. 77 is clearly made up of 7 and 11, both of which are prime factors. So that means the green numbers here are the prime factors of 3465. For 1350, I'm going to use a slightly different method. Clearly that's divisible by 10, so we'll divide by 10. And that means that we've got 135 divided by 10. The factors of 10 are 2 and 5. 135. 1 plus 3 is 4, 4 plus 5 is 9, 9 is divisible by 3, so 135 is divisible by 3. Divide that and we get 45. 45 is divisible by 3 to give us 15, 15 is divisible by 3 and it gives us 5. So there are all the prime factors. The difference between this method and this method is that here all the factors are in ascending order. In this method we've got 2, then 5, then the 3s, and then the 5s, so the order is a bit different. Okay, for the last number I'm just going to go back to the first technique, which is 3150 divisible by 2, giving us 1575. That's divisible by 3, giving us 525. That's divisible by 3, giving us 175. That's not divisible by 3, but it is divisible by 5. Divide by 5 we get 35, divide 35 by 5 and we get 7. So these are now all prime factors. We've now got all our factors and I want to put them on a table. So let's just move the page down a bit to give us a bit of space. We'll draw our table. And now what we're going to do is we're going to gather all of the factors in order and put them across the top line here. Then we'll take the factors of 1260 and put those in the proper columns, then the factors of 3465 and so on. That's all the factors of 1260, 3465, 1350 and finally 3150. Notice how these are stacked up. We've only got 2 2s. This number's got 2 2s, this number has no 2s, that's got 1 2 and that's got 1 2. So the maximum number of 2s we have is 2. This has got 2 3s, this number's got 2 3s, but this number's got 3 3s, which is why we've got 3 columns for 3s. This number's got 2 5s, this number's got 2 5s, there's 1 there and there's 1 there, so we need 2 columns for 5s. That's 1 7, there's 1 7 there, so we need 1 column for 7 and 1 column for 11. We put the numbers as far left as they can go. Now, for the highest common factor, we just look at the columns that are full. So, for the highest common factor, this has got a number in, this has got a number in, and this column is full. So the highest common factor is 3 times 3 is 9, times 5 is 45. Now for the lowest common multiple, we actually use all the columns. So we have numbers in all of the columns, and the product of those is 69,300. Now finally we have to do our sanity check. So first of all, if we're saying 45 is the highest common factor, we need to divide 45 into all of these numbers here. And they're all integer, which is good. And then the next question is there a common factor in those numbers? Well, 28 has obviously got a 7 in it, and so does 77, and so does 70 for that matter, but 30 doesn't, so 7 isn't a common factor. 28 is made out of 4 times 7, which means that there's a factor of 2. There's a factor of 2 here and here, but not here. So there is no common factor there, so we're probably right that this 45 is the highest common factor. Now for the lowest common multiple, the number 69,300 should be factorizable by all of the original numbers. So let's do the divisions. And now we need to check these numbers and make sure there are no common factors here. 165 has obviously got a 5 in it, so is 60, but 154 and 66 don't. So 5 isn't a factor, 2 isn't a factor, because 2 is not a factor here, 3 isn't a factor here. So again, there are no common factors, which means that we can be confident that our two answers here are correct.